All right, well, it's just about showtime. We've got time to start here on our end. Thank you for joining us for this webinar on contaminant controls. We're going to talk about some techniques and products that will help curtail contamination in both the high and the low sides of the system. And a big thanks to Heatcraft and Don Fort for inviting Sporlan to participate in this program. So we're just trying to finally get set up here, and we're starting now. Hello, I'm Jim Jansen. I'm a senior application engineer for Sporlan. I've been with Sporlan for a good long while, and I've done a variety of jobs along the way. That's me on the left over here. Of course, you're seeing a video image of us. And if everything is working today, like we hope it does, we're broadcasting the images of both of the speakers. Joining me today is Kevin Freeman. This is Kevin right here. Kevin's a senior application engineer on the Sporlan technical support team. Kevin's one of those rare guys that's been with us for 30 years, right? Over 30 years.
A little over 30.
Now, you've had a variety of positions during that time, ranging from quality control stuff to product management. There's a better than average chance if you called us on our tech support line, that you might have gotten good expert help from Kevin on any of our products. We're really happy that he's with us today. And we've got provisions here for you to ask questions. As best we can, we'll try to field those questions. If you pose questions to us we can't answer, we'll make something up. I'm kidding. We'll get an answer for you and get back to you if you stump us. And just so that you know, you can always contact us in the future at our tech support. That's svdtechsupport@parker.com for email, or you can always call our general number for our headquarters facility at 636-239-1111. That's a general number to get into our headquarters building, and you can get your call directed appropriately if you needed tech support on any of our products going forward. This is a slide that we like to use that shows the 4 main components in a vapor compression refrigeration cycle. No matter how complicated the multiplex system might be, there's still only 4 main components in that system. And here we've highlighted them. They're, of course, the compressor. That's the heart of the system, if you will, and helps the high and the low sides to exist so that we can have phase change with the refrigerant that circulates through the system. And then, of course, here's the condenser. That's the high temperature, high pressure heat exchanger that does what its name implies. It condenses the refrigerant vapor that flows through it and turns it into a liquid. Then, of course, over here we've got an expansion device depicted here as a thermostatic expansion valve. And in this particular case, that device is meant to control superheat where the bulb's located. An expansion device in general works in unison with this compressor to have a pressure drop that is more or less equivalent to the rise in compression that took place in the compressor. And then, of course, here we have the evaporator as that 4th component I was talking about, where we are absorbing heat, transferring heat from a space that we're trying to cool or refrigerate. 4 main components. Now, here's a more complicated image. This shows the complete vapor compression refrigeration cycle. Even though we've got a lot of additional componentry shown here, we've got oil management system over here, we've got a lot of high side liquid controls over on this side, and then evaporator pressure regulators, and then, of course, the parallel compressor bank. Even though this is somewhat complicated, there are only 4 main components in that system, just like we said in the previous slide. Even with all that, this particular image is quite reduced from what you might encounter in an actual supermarket environment. But today, we're mostly going to talk about, or at least we're going to start conversation here on the high side with the liquid side components. If down the road, Don asked us back, there are other devices that we can emphasize with some of these same techniques. We can talk about mechanical subcoolers, we can talk about liquid pressure regulators and solenoid valves on the liquid line applications, as well as filter dryers. Now, this is an actual image of components that we've inspected following warranty returns of products. In fact, Kevin, you've probably actually seen some of these types of devices that have come back that are completely crowded with junk like what you see here, right?
Oh yes, many times.
Now, our filter dryer is purpose-built, or any good filter dryer is purpose-built to remove contamination from the refrigeration system and protect system components. Anything in a system besides refrigerant and lubricant, sometimes referred to as oil, is considered a contaminant. The catch-all filter dryer is designed to remove these major contaminants, which consist of moisture, acid, sludge, varnish, and even waxy substances as well. As you can see on this slide, we're talking about material you don't want in the system. You know, contamination is anything that is any unwanted material in any unwanted location. And contamination is one of the single biggest culprits on compromising the operation of the system with respect to these things: reliability, capacity, efficiency. It's one of the single biggest things that causes the system to malfunction. And to use some of Don's words that I've heard him say in the past, you want the system to be clean, dry, and tight. So we want it to be clean and free of any contamination. We want it to be free of moisture, which is also a contaminant, and we want it to be leak tight, leak free. And contamination can be introduced from a number of things. For instance, it can be introduced when the system is manufactured. And I don't want to point fingers at anybody, but sometimes that can happen. It can also be introduced while a system is constructed in the field. It can be formed during operation. When things go awry in the system during normal operation or abnormal operation, as the case may be, contamination can be generated. Now, but there's good news on all of this. There's ways to control it and corral it and alleviate the problems that it can cause. Here's more information on the primary contaminants and what problems they create for us. If we look here and talk about water or moisture, it plays a role in the formation of acids in a system. If sufficient water exists in the system, the lubricant and or the refrigerant can react with the water and form an acid in the process. I believe that's called, well, there's a $10 word for that, called hydrolyzation. With the common use of POE lubricants, this is certainly a potential issue due to the hygroscopic nature. You know, it's so water hungry, right, Kevin? You know, it's the POE has an affinity for moisture, so to speak.
Absolutely, Jim.
Now, as I recall, and you might know more about this than I do, but alcohols and acids are actually processed to form POE lubricant. And there's a byproduct when that takes place, and it's actually water.
Correct.
Yeah. So does it make sense that you could reverse that operation? If you had POE lubricant circulating through the system and you had an unreasonable amount of moisture entrapped, you could revert back to alcohols and acids being present in the system. Does that make sense?
That would be absolutely correct, Jim.
Now, foreign matter originates from a variety of sources, like we said earlier: oxide, scale, metallic fines, fibers, and the list just goes on. This stuff can be introduced into the system during assembly, during construction, or service. And keep in mind, some of these lubricants, like POE, do a really good job of suspending and transporting large amounts of debris if it's in the system. And POE is also a reasonably good solvent and has a scouring action. And if there is stuff that's plated out, it could possibly break that loose. And then you might have sludge and varnish as byproducts of lubricant decomposition along the way. And even waxy substances can originate if you've got a low temp system. We still see that on occasion. That's maybe not as often as what you used to have in the era of CFC refrigerants, but still does take place, if I'm not mistaken. Before I go on here, Don originally said we had a question or two.
One question is, what is the temperature at which the paint on a filter dryer will melt or burn?
Okay, that's an interesting question. I can guarantee this: if you put a torch to it out in the field, you're going to burn it and deteriorate it. That's a tough one. That usually comes up because you've got a filter dryer that is being sweat into the system. Oftentimes, a lot of times people will want to install that out at the condensing unit, right? That's where you see them a lot of times, Kevin. We'd rather see that filter dryer right there at the inlet of the evaporator where the expansion device is located, so that you got good protection for it there. I don't know the exact point at which that epoxy powder coat starts to deteriorate due to heat. I know that it is certainly compromised by the heat from a flame on a torch. So maybe all the more reason to be mindful of that when you're brazing it into the system. You got anything to add to that, Kevin?
But then, like I said, we've always recommended that you definitely direct your torch flame away from the shell itself, and it's always a good idea to have it wet ragged or some kind of a protection thermally to prevent from burning that paint.
That's a good question. Don, you have to keep pointing those out to us. For some reason, that's not showing up nicely for us.
Well, there's one more before you pass on and talk about the types of desiccants you have. So here's the other question that I see posted, and that says, now this question, it says, if I'm evacuating a system, will the moisture pass through the filter, or so he says pass, I think it means passing through the filter dryer, be taken out, or will it be trapped in well, it says the teeth of the filter, but it's in the desiccant, right?
Yeah. Well, that's an interesting question. I'll tell you what, if you'll hang on a minute and let me get another slide or two into this presentation, we might have a pretty good answer for that.
I think so.
How's that? All right. So as we continue in this discussion here from the previous slide, to eliminate the problems that different types of contamination bring to the system, appropriate materials are deployed and like our catch-all with a blended core to help resolve that. For instance, molecular sieve, which you see here, and I'll try to get the laser pointer to work here again. The molecular sieve that you see here is very effective at removing moisture from the system, as it has a high affinity for moisture itself. Activated alumina also has moisture bearing capabilities, but it's better suited to handle any acids that might be in the system. In fact, activated alumina is one of our best means of combating any acid that might form in the system. Activated carbon is able to remove oil breakdown material and waxy substances. And in fact, if you have no clue what the junk in the system might be, an activated carbon-based filter dryer would really be a good way to attack it. And activated, that's just a way of driving moisture off of desiccant material. So when we're manufacturing contaminant controls, or we're building a filter dryer, one of the things that we do is a process that activates the desiccant material. We take it up to an extremely high temperature and drive that moisture off the product. And since it's kind of tough to ever predict what kind of contamination might actually be in the system, and depending upon what type of operational issues you've encountered, a molded core with a blend of these desiccants would be an interesting way to approach solving that problem. Now, we're going to start getting into a point where here I can kind of answer the question that got posed to us, Don. This graph that you see here, right here, predicts the performance of molecular sieve versus activated alumina in a moisture contaminated environment. This was information that was acquired from a third-party test evaluation performed a good while back, but it's still very valid. You can see here both desiccants remove moisture over the range of the moisture that you might find in a system. However, the range of water that is typically present in a refrigeration system shows that molecular sieve vastly outperforms activated alumina in these ranges. Again, molecular sieve absorbs water molecules in the small pores of its structure, like is depicted over here to the left. So let's just take a look at this for just a second. This is actually an adsorption process where the molecular sieve has a molecular phenomena that takes place. It's interesting. I don't know if that's on your end, Don. Can you hear that? Yeah, it's gone now. Well, good. The absorption of moisture by molecular sieve is actually a molecular phenomenon, and it does not affect the flow capacity through the core around the molecular sieve granules. So now these pores are too small to absorb larger molecules. For instance, organic acids generated by or from a lubricant decomposition or from any of a number of malfunctions would be better suited with the irregular structure that you'd see in the larger pore spaces of activated aluminum as far as trapping that. Now, if you're pulling a vacuum on an existing system and it's been wet and you suspect that, of course, the molecular sieve that's in a filter dryer has done its job, I think that makes the argument for you to do as good as you can at that point. But we've got a list of reasons why you would replace the filter dryer. And anytime you've gone into a system and done any kind of service whatsoever, we suggest that you make a replacement and renew that filter dryer. I don't know, that's sort of a left-handed answer to that question. But here, let's take a look at some more stuff with respect to this. Now, if you consider excessive amounts of moisture in the system, like take a case if you've got a chiller barrel and you've ruptured and it's had a rupture in it and you have a system that's full of water, you might see water in the range of getting close to 100%. You flooded the system with actually liquid water. And in that case, something like activated alumina has a crossover point here where it starts out performing molecular sieve from that standpoint. And if we take a look at the vertical column over here, you'll see that we've plotted units of absorbed moisture versus so many units of absorbent. So it's sort of a unitless feature, but it's just, we're talking about the desiccants that we're using to collect the moisture in this case. Down here, this is what we would expect to see in a vapor compression refrigeration system. This typifies something where you might actually experience liquid moisture circulating through the system. From the molecular aspect of how molecular sieve functions, if it traps contamination, you've got to go through a lot of processes to drive that out of the core itself. And I'm thinking the better way to look at that, if you have reason to believe you still have acids in the system, you still have moisture in the system, and you've done all the things you know to do, it's time to renew the filter dryer's capabilities and replace it, and then continue on with the process that you're doing to try to clean it up. Now, filter dryer construction varies by manufacturer and even within the product lines of any given manufacturer. In fact, Sporlan has made solid core filter dryers for years. We've also made loose filled or compacted bead dryers as well. And over time, there's always been a thought that a loose filled version can experience some desiccant attrition. In other words, these beads could vibrate and abrade one another, and that due to that process, you might actually have small particles of the desiccant actually released into the system. That's certainly always been a concern with filter dryers of this design. The argument can go the other way too. You know, they can say, well, if you've got a molded core and if it's abused or roughed up, it could break, and then you've compromised the abilities of that as well. And that, you know, that certainly is a possibility. We've offered a low-cost, spring-loaded, granular-style filter dryer in the past that was loose-filled or a compacted bead. We've started phasing that out of the process, right, Kevin? Is that no longer in the lineup currently?
Correct, yeah, yes.
And where were those? Those were typically used to do what, Kevin? Those were sold mostly for?
Primarily OEMs. It was a lower cost option.
For like R22 air conditioning, for instance, that sort of thing?
Correct, yes.
Okay. But but it was mostly a low acid capacity, primarily targeting moisture affinity and tending to entrap moisture. Due to that low acid capacity, we would have never suggested this for servicing equipment in the field. We would have said a better way to approach that would be with a blended solid core like you'd see in a catch-all, and that would target the many contaminants that exist in a refrigeration system, and we could eliminate that and then avoid the possibility of any desiccant breakdown or attrition in the process. Now, large systems typically use replaceable core style catch-alls like you see here. The replaceable core products are generally larger compared to the sealed models. What's a downside of that, Kevin? Would you more refrigerant in the system if you install this?
Definitely, you would have more liquid refrigerant that would have to be added to the system.
Okay, and then also, you know, there's a cost issue with this, but this allows the service technician to service the system by replacing the core and or any optional secondary filter. This device shows a secondary filter to help even clean the system up even better. You would do that as opposed to replacing the entire unit like you would do with a sealed model or hermetic model. This optional secondary filter is a good addition to the system in conjunction with things like POE lubricants. I sometimes joke and call them a solvent, but I mean POE lubricants. POE lubricant, again, can exhibit a little bit of a scouring tendency. So if it's an existing system and it's been a retrofit, you can experience times where that might actually break some of the plated or contamination that's been existing in the system for a long time, might break it loose. The secondary filter really helps to clean up afterwards. Like the sealed models, the replaceable core catch-all can filter down to 40 microns, and the addition of this optional secondary filter can take that all the way down to 20 microns. So it's as effective as most any other device you're going to encounter. The replaceable core type catch-all filter dryer had been manufactured with some different internal components over the years. In the late 90s, it was significantly redesigned, and the internal assemblies of our size C480 through the C19-200 series shells, incorporating a center strainer screen tube construction as the final filter, as you see right here. That design change provided helped with ease of assembly and offered different filtration options to service contractor. The current shell is designed to be used in liquid line applications with replaceable molded cores. An optional secondary filter is still available, and it's recommended at startup and for cleanup in the aid of filtering out undesirable small solid contaminants. You have to be careful when you use that with molded cores only. The replaceable core type catch-all filter dryer provides a nominal filtration ability down to that 40 micron size at a decent efficiency. I think it's like 50%. When you add that optional secondary filter, of course, we can filter down to 20 microns. Now, as we move into considerations for cleanup outside of the high side, which a lot of these products are intended primarily for liquid line applications or high side application, I guess the general consideration is that you do your best job of collecting moisture out of the system at higher temperatures from liquid. And that's been part of the argument for using liquid line filter dryers for years. But for certain cleanup applications, it makes sense to have suction devices being addressed as well. We've got a number of replaceable shell catch-alls. While they're primarily intended for liquid line applications, and those with the center tube construction are designated appropriately, that center tube construction allows easy installation of cores and the availability to use that optional fine filter. And you got an outlet retainer plate design, which would be possibly too restrictive for suction flow applications, but you could use it there as long as the line sizes are of the appropriate size. as it says here, permissible for suction flow, but only up to 1.1/8 line size. That's something to keep in mind. And as you can see here in this diagram, we show the optional fine filter for liquid application installation only on the liquid side and not on the suction side as it would be in entering the compressor. That center tube construction, which we've shown you a little earlier, may restrict flow if it's used in the suction line on larger systems. Now, if we just, this is again more emphasis for that clean, dry, and tight mantra that Don's promoted in the past. We, do cleanup of large system well to ensure that we protect things like thermostatic expansion valves and electronically actuated valves. The TEV and the EEV are excellent secondary filters, strainers, if you will. If you have a debris-laden system, they're going to help you clean it up. But then what's going to happen is you're going to have devices that are full of junk and debris, and you're going to have to replace those. That secondary filter can capture small particles that the core can't, and cleanup is complete when you have that clean, dry, and tight condition achieved. You see a number of different images here for our contamination devices and some coloration differences. That ultimately comes from the clay and other elements that are actually present in the materials that are mined to create these different styles of cores. Over here, the RCW device is mostly intended for applications where you're trying to clean up moisture that might be in a system. Here, the RCA has activated alumina in the mix, and it has overall the best acid capacity. That's something that might be unknown to many. They tend to think that our HH style core with the activated carbon is actually the better acid removal core, when actually it's really good at overall system cleanup and getting out decomposed oil and the residue of burnout. And a good practice would be, if you're cleaning up after burnout, to have a suction line device with the HH core, and then of course our RCA in the liquid line side. Now, waxy substances can also plague low temp R22 systems. That happens. Here's some argument that shows the fact that a thermostatic expansion valve, which we have depicted here, can actually help to filter out some of this debris that's in the system, which is not what you want to have happen. But wax can fall out of solution at the pin and port during expansion. That's a place where there is a great big pressure drop and a huge change in temperature, and it can help precipitate debris that might actually be in the system. Waxy substances can travel in solution with refrigerant and oil, and wax is generally not realized until that refrigerant experiences a big pressure drop, like we mentioned, during the expansion process, causing the substance to precipitate out of solution and collect at the pin and the port. Kevin, what would be a possible source for that wax in the first place? How does wax get in the system?
The source of wax could be residual process fluids such as paste flux, drawing oil, remnants from the manufacturing process, and the deterioration of the lubricant used in the system. Mineral oil contains some amount of paraffin wax.
And we still see some mineral oil in systems, right? That's not going away just yet altogether.
Not completely, yes. It's still there, and so you count on the TV to be the best secondary strainer in the system, and it will collect contaminants if you don't do something else about it.
All right, so all the more reason to take good measures to clean up the system. Now, systems that run high condensing pressures and temperatures are likely or could generate oil breakdown. What do we mean by oil breakdown?
Well, the higher temperatures are going to cause the lubricant to fail, basically. It no longer has the lubricant properties. It can cause problems. Oil breakdown will continue to, or has a tendency to collect at the TEV on the pin and the port and affect the operation of the valve.
Okay. All right. So I think there's a $10 word for that, that some of our product managers in the past would call that polymerization. Don?
Jim, there's
question?
questions on the board. Maybe we might take a little pause and see if we can get
Sure.
caught up in those.
Sure.
All right. First question that we didn't get before. I think we'll talk about that at some point, later on in the presentation. It says how to size or select a catch-all filter dryer. So,
Okay,
size selection would be one thing.
Okay.
And then hold that. And then we've got probably about 3 more questions here on top of that. One of our participants says this. He says, I sometimes see filter dryers specified or described as standard capacity or high capacity. What is the difference between these types of filter dryers, and when should a high capacity filter dryer be specified or used?
All right. So you want us to field that question first as opposed to the selection?
Yeah.
Okay. Standard or high?
Will you be answering the sizing question first, though? I mean,
I could go ahead and address the sizing question at this point.
Okay, go ahead.
Yeah, I mean, in general, we've got a couple of different methods to go about the selection process. One, we've got literature that's available to coach you through that, and you can access that literature from our website. It's free of charge to download. You go to www.sporlan.com, get to the literature page, and download any of our information on contaminant controls, and it will coach you through the process. You need some basic information to select any of the devices that are going to function in a vapor compression refrigeration cycle. Things like what refrigerants in the system, what's the capacity of the evaporator, high and low side temperatures and pressures. And with that kind of information, and depending on where you're planning to install the contaminant control device, we've got ratings tables that will coach you through that. Now, another way to approach that is to use our software program that will take that same kind of information and will do the selection for you. We have a virtual engineer software program. I'll a little later in this slide presentation, I'll show you where you can access that. That's another tool that's free of charge for you to use. It is an online device you have to have an internet connection to access it and to use it. And it will step you through the process to select any of our products, including contaminant controls. And it will include selecting contaminant controls for liquid line application and suction line application. And we'll coach you through that. That's another way to achieve that. And also, you can call Kevin. Ask Kevin for help. Kevin will do the selection for you. All right. That's another good way to get expert help if you're a little concerned about whether you've done a good job or not, or whether you need to consider some other things. Kevin is very good at coaching you through that process. So virtual engineer is a real good way to go about it. I'll show you where to find that later on. Now, the high capacity, standard capacity, that depends. I will sometimes hear of instances where if the system is a manufactured system, it's sealed up by the OEM, there will be one size. If a filter dryer is included, there will be a size of filter dryer that's commensurate with the fact that the OEM's done a nice job of getting all the contamination out of the system, and it's clean, dry, and tight. And they've installed a contaminant control device that's commensurate with that. If you're doing a project out in the field and you have reason to believe that it's contaminated, maybe there was a burnout, maybe there was some other failure, it is advisable to take that up a step. And we have different ratings for whether the contaminant control device is being added in an assembly environment at an OEM or whether it's a field service environment. And then we also have recommendations if you're following a burnout and trying to clean up after the fact on that, you would do things like might go into our ratings tables and do a standard selection, but then increase it to the next model size up to add additional desiccant into the mix, so to speak. And I think maybe that's what they're talking about. Or they might be referring to a sealed model catch-all versus a replaceable core. And inevitably, you're going to have more desiccant material, or you have the option to have more desiccant material if you go the route of a serviceable replaceable core model. Kevin, you want to add anything to that?
No, that sounds good. Like you say, the replaceable models have the serviceability standpoint. So
something to consider. And it kind of depends what the application happens to be. You fall in a burnout, are you doing a new field built up system that you've done a good job, you've done nitrogen purge, you've pulled a vacuum, everything's in good shape, or are you servicing a unit that's had a compressor failure and you have acid present. And if you have acid present, well, we're going to talk to you about that here just shortly. In the case of this particular contaminant control device that we're showing you right here, it is particularly effective at removing oil breakdown material and waxy substances. It's also capable of removing acid, moisture, sludge, but it's really a cleanup style device. Acid and moisture are generally better removed with our standard RC 4864. Moisture with our RCW 48 because of the types of desiccants that are included. That HH is really recommended for system cleanup following a compressor burnout. A good thing to do is to consider putting that in a suction line, then keeping a close eye on it, watch the pressure drop across it, and when it gets to be what, Kevin, 2, 3, 4 PSI, it needs to come out. You put a fresh one in and you run it again.
right.
And then ultimately, if you have decided to install one of these in the suction line following a burnout, you would not leave it there indefinitely. You would eventually take it out and either install a suction filter or just a spool piece of pipe.
Correct.
All right, and there's another adjacent question connected to that as far as the core filters are concerned.
Okay.
One question was, is there a recommended time between when you open a replaceable core filter and the time that you put it in the system and evacuate?
Yesterday. I'm kidding. You want to add? You want to take that one, Kevin? You understand what he's?
Correct. Yeah. Naturally, we don't want you opening those up until you're absolutely ready to put them into the shell and install it and seal the system up. It's definitely the longer they are exposed to atmosphere, and depending on the conditions you're in.
Yeah, humid or not.
Yeah, whether it's in the dead of summer with a lot of humidity versus wintertime conditions, and even air movement will affect how fast moisture will be drawn to the dryers itself. So be ready to install it, do this quickly or as soon as possible, and seal the system up and pull a good vacuum.
Okay. And now the same individual mentions this when you were talking about solid contaminants. It says, by solid contaminants, do you mean the metal thrown off by a scroll compressor, or what are you talking about where it comes from?
I'm not so much concerned about its source necessarily, but if the question is, what is a contaminant? I'd say anything that's in the system that's not refrigerant or lubricant is a contaminant. And if it happens to be metal fines that are generated by, say, the scroll compressor that's wearing in like they normally do, I mean, that's potential contamination. I mean, copper chips, brass chips that might be left over from the manufacturing process from anybody that's supplied components is contamination. Drawing fluids, I mean, I don't know. We had a rash of problems here a few years ago in air conditioning systems where there was some process fluids that were residual to the system that were coming from a particular component that was installed. and they were wreaking havoc with expansion valve operation. And it didn't matter whether it was one of our valves or any of our competitors' valves, they all tended to foul after they ran for a certain period of time. And it was really a big exercise in an attempt to find the source of that contamination, but ultimately we did. But I guess the answer to the question overall is anything that's in the system from our point of view that's not refrigerant or not the lubricant that you need to keep the compressor alive is a potential contaminant, and we'd like to make sure that it's not in that system, because eventually it's going to get someplace where you don't want it to be. And oftentimes it's in one of our controls and causes it to malfunction.
And the next question, I don't know if this was supposed to be a little levity, but it says concerning the HH on the filter dryer that you're, or the cartridge you're showing here on this slide.
Yes.
Does HH stand for Harry from Husband?
That's an interesting question. Depending on who you ask. The chemist product manager that was on board with us years ago when this was formulated was Jack Hoffman, right, Kevin? Jack Hoffman.
Yes.
We had the privilege, both of us had the privilege of working with Jack a little bit. It was developed for applications with Hussman. So if you ask Jack Hoffman, he would say the HH is for Hoffman and Hussman and not necessarily in any particular order. If you were to ask Harry Lange or Herman Spohr, the two founders of our company, they would say, well, that stands for Harry and Herman. There's nothing written down. So you take your pick.
All right. And then one final question before you push on. And it's this: what is the effect of installing a filter dryer backwards?
The thing, if you put it in reverse and it's not intended to be utilized that way, we do have some filter dryers that are biflow in nature, right? You know,
Right, with a different internal construction though.
Right. The construction of it, and it would probably be best if I were to have the cutaway view of the filter dryer in front of us, but we have placed components inside the shell that are filtering in nature and then desiccant removal in nature. And you compromise that if you install it in reverse, if you will. And that's as good as a way of saying it. I've got another image here where we can go back to that question, and I'll show you the image and what I mean by that. If that's okay, Don, we'll back up to that here. And I think I got one coming up. If not,
I'll hold it for questions until after the presentation after this.
Okay. You got anything else you want us to address right now?
No, I think we're caught up with that now.
Okay. All right. Well, don't let me get away without showing you the cutaway of a filter dryer again before we can, unless there's other questions that come up. One of the things that we mentioned before is the presence of acid in the system, and it's, well, how do you know if you have acid or not? And one way to take a look at that is if you can access an oil sample. We have acid test kits that are available to do an on-the-spot quantitative test. It's not as perfect as a full-blown evaluation by a chemistry lab, but it gives you an overview of what's going on. If you mix with the correct vial to create a solution and you compare the color on the chart like you see here, we've got a single-use kit that'll give you an idea of what's going on in the system. We got separate vials are provided for POE lubricants and mineral alkylbenzene oil systems. And when the acid level is high, you really need to address that. And good recommended practice is to change that filter dryer and monitor the acid level until it gets to an acceptable or non-existent level. And you will need to replace that, that filter dryer to replenish the contaminant holding capacity. We'll sometimes receive contaminant controls of a filter dryer, if you will, and the complaint will be that it has excessive pressure drop across it after it's been installed in a system. What would excessive pressure drop across a filter dryer indicate to you, Kevin?
That it's working. It's actually collecting contaminants, and that are in the system, and that's what you want it to do if they're present.
It's done its job. Another device that we make that is good to be used in unison with a filter dryer is a device that can be used to give you a visual estimate of what's going on in the system. Moisture levels in systems can increase over time if you've accessed the system or leaks have formed. This See-All device is a combination moisture and liquid indicator. It'll identify when a system has moisture that's reached a cautionary or even a dangerous level by nature of salts that are impregnated into a special paper that is put into this assembly. Green will indicate that it's in a dry environment. As it changes color to chartreuse, you can see that we're in a cautionary level. And if it goes to full yellow, well, then it's wet. It's reversible, provided it doesn't get drenched with moisture. It's reversible. It'll go back to green in time. If this remains yellow, it's probably time to do some service on that system and replace the filter dryer. Prior to installation, you pull one of these out of the box, and at a wholesaler, if you will, it's likely to exhibit a chartreuse or even a yellow color, depending upon the humidity level in the building where you happen to be. That's just simply due to that exposure. Once it's installed in the system and a deep vacuum is pulled, the moisture indicator should change back to green unless there's still water or moisture in the system. It will change color to indicate system moisture level once the system has had some good runtime and things have reached a good steady state. Another feature of this device is its ability to give you a snapshot as a sight glass. For instance, if it is placed here, as you can see at the inlet of a thermostatic expansion valve, you can see if there's a full column of liquid entering that device. So it serves those purposes, and it's in many ways, it's a very simple device to select. It's a line size type of device, and it's usually a matter of just simply matching up to the line size and selecting what type of fitting combination you'd like to have, be it flare or sweat. There's many combinations of this, a whole host and plethora of versions, and like we see here. Kevin, what's special about what we see here?
Let's see.
It's serviceable.
Correct. You've got the indicator that if you needed to remove it from the bottom side of the sight glass, you can do that, and we do sell that.
We sell that, a kit for that, to rebuild that?
Yes, we do offer a kit for that. Whether it's a problem where the salts have been washed out, or in this case you wouldn't with flare connections, but sometimes on the ODF solder sweat ones, we see them get burnt during installation.
And in fact, I go back here, these, green, it's dry, chartreuse, it's cautionary, yellow, it's wet. If it happens to be brown, it might be contaminated with debris. If it's black, it's likely to have been overheated.
Correct.
If it's showing no color at all, there's probably enough moisture in the system that it's washed the salts off this paper.
Yeah. And
that can happen.
Yes, it'll wash it out to basically appear totally white.
Now, as is the case for catch-alls in general, we also make suction filters in sealed and replaceable element models. And so, as its name implies, you'd use a suction filter and you would install it in the suction line, and it would be for filtering operation only. And it's a good device to help protect the compressor. These have no moisture acid removing capability and serve only to protect the moving parts in the compressor from fine pieces of dirt, chips, filings, and other particulate contaminants. A number of the seal models are furnished as a standard with something known as a bypass relief feature. Now, Kevin, what's the purpose of that bypass relief feature?
The purpose is for to avoid excessive pressure drop in the suction line. This would occur if the filter collected enough dirt to restrict the flow sufficiently. Excessive suction line pressure drop could potentially damage the compressor.
All right. Now that's an important feature, is it offers protection to the compressor from operating with insufficient cooling at unusually low pressures. That suction filter won't release dirt that it's collected when operating back, and if it's in the bypass mode. Now, there are some people who say, well, you're not doing any filtering if you're in a bypass mode. And you've got a point there. And you gotta decide what makes more sense for the system that you've designed. You want that bypass feature involved, which even with the flow directions that the refrigerant has to undertake, there's some ability for debris to be knocked out due to the flow changes, but you don't have the full effect of the filter. Or you shut it, let it plug off altogether. The shell for the replaceable element model is nearly identical in construction to the shells of replaceable core catch-alls. The most noticeable difference is the size of the connections for a given shell size. Catch-all cores and pleated filter elements can be used interchangeably, which makes its use really pretty convenient for large system cleanup. After cleanup is completed, using catch-all cores during the cleanup process, the cores could be replaced with pleated filter elements on a permanent basis to reduce suction line pressure drop, because the Filter-Drier version is going to have a pressure drop than just the filter element would have in that similar kind of application. It should be noted that when using pleated filter elements, the replaceable suction filter is bidirectional, meaning this is a device that can be piped to flow in either direction, but not both. However, if cores are used for cleanup rather than a pleated filter element, the side connection for that shell must be the inlet. That's just function a whole lot better if you take it that approach. When the replaceable element suction filter body is installed using catch-all cores for cleanup, an additional final filter screen should be installed as a precautionary measure. And that's one of those things, if you were to install a seal model catch-all in reverse, you would not have that additional screen in the right spot. I'll have a slide here in a minute that'll show that. Additionally, the pressure drop should be monitored so as to not exceed the value shown in our supplementary bulletin, which you can make out here, depending upon the application. Now, in this slide, we have a cutaway image over here on the side of a catch-all. And Evan, this is the inlet over here, right?
Correct.
Yeah,
yes.
And what's going on right here? What's this?
This is basically just to keep that core tight, so where there's no give, it's holding it tight in there.
So you wouldn't have the core banging around and possibly debrade and have a failure there.
Correct.
Now, what's here?
That's the polyester outlet pad.
Okay, what does that do?
That's going to catch any small fine particulate that might come off of that core.
It's a filter.
And it'll prevent anything from going back out into the system. So the adverse thing, if it was installed backwards, that pad would clog up prematurely, and you'd cause a premature plug up of the dryer.
And plus you don't have this core has been molded and shaped to facilitate refrigerant flow to encompass its outer perimeter, so that we take advantage of the desiccants that's included in it, and then finally to go out through the final filter.
Correct.
And so that gets compromised if you install it in reverse.
Correct. Yes.
But the whole gist of this slide is to talk about why you would replace the filter dryer that's already out in the system. And of course, we contend that an initial system installation should have a filter dryer. If the system's open for any reason, for any kind of service or repair, you should put a new filter dryer. The liquid line catch-all filter dryer pressure drop exceeds at a, I think that's really excessive, 5 psi. Again, it's kind of funny when we get a complaint that the filter dryer it's exhibiting high pressure drop. Well, it's done its job. It's time to replace it. It's sort of like toilet paper in that regard. You use it once and throw it away. If you happen to have a moisture indicator, a sight glass moisture indicator, CL if you will, if it shows the presence of moisture, if it's in a cautionary or wet mode, it's time to service the system and dry it out and put a new filter dryer in. If you use some type of acid test kit and it indicates that there's acid present, it's time to put in a new filter dryer. If you're repairing a system that's suffered a compressor burnout, at a minimum, it's time to install an oversized liquid line filter dryer to help with that. And if it's a really major compressor burnout, like you've got excessive amounts of acid present, you would install even a suction line catch-all to help with that process, and maybe use the HH style core there and monitor that for pressure drop as well. And following a successful cleanup, after you handled that burnout that took place and you removed the contamination, and now you feel like you've got a clean system, all the more reason to now have a fresh catch-all or filter dryer in there to ensure that you keep it that way. That's a common, Don, this is a real common question that we oftentimes get, and that's why we try to come up with these different ways to help keep, I like your mantra there, clean, dry, and tight. Now, what is one of the worst threats to good system performance? We've said it a number of times, it's contamination. There was a time when the 100 mesh strainer was thought to provide all the protection needed to prevent system breakdowns. We put 100 mesh strainers in front of a lot of our devices, and that's what this is depicting. The 100 mesh strainer is still essentially a standard screen size used on the inlet of a lot of our TVs and other system components. But these strainers are designed strictly for protection against large pieces of solder, scale, I like to say hammer handles and lunch boxes. The image on the slide illustrates a magnified view of a 100 mesh strainer screen, which has collected some copper oxide produced by brazing copper tubing, and then it's almost unbelievable. The large particles were caught by the screen, but there's a lot of smaller stuff that passed right through it. The image on this slide provides a perspective on particle sizes as comparative dimensions are illustrated. In this example, particle size is expressed in terms of microns. So what's a micron? A micron is defined as 1/1000th of a millimeter. The 100 mesh screen shown on the previous slide has openings of 150 microns. So now this kind of gives you a perspective of what we mean, one hair, 100 microns, lower limit of visibility, 40 microns, and so on. In view of these comparisons, it might appear that a filter designed to remove particles the size of 3 microns would be overkill. However, in the case of an oil filter applied to a refrigeration or air conditioning system, the removal of particles in the ranges of 2 to 20 microns can be an issue when the nature of that particle happens to be abrasive. That means it'd be a good idea to remove even these small particles that you might actually even have trouble seeing. Very small particles of an abrasive material, such as iron filings, when in sufficient quantities, can lead to adverse bearing wear. And how do we know? Well, let's take a look at this next chart. There was a test that was done, an evaluation by an engineer known as Mcpherson, if I understand. Well, this particular test involved a fairly well-known study that was done on aircraft bearings. And it proved the removal of very small particles from lubricating oil had a very useful effect on the life of bearings. The finer the filtration, the longer the bearing life. And the plot of that data was called a Mcpherson curve. That's what we're showing here. So we take a look at the chart, and you've got relative bearing fatigue life, starting down here at 0 and going off into the great beyond. And then you got particle size measured in microns. And what this is showing The larger the particle size, the shorter the fatigue life of the bearing. Now, that's a relative scale. Larger particles reduce the life of rotating device, like in a compressor, by plugging up journals and oil passageways and scoring internal surfaces and damaging the bearings. This is kind of why you change oil in your car once in a while. Now, clean refrigerant oil has always been important. However, with the use of HFC refrigerants, which are still on the market, which require a POE lubricant, which again we'll sometimes jokingly call solvent, the importance has become even greater. Unlike mineral and alkylbenzene, POE has that solvent tendency. POE lubricant has the ability to suspend and recirculate those small contaminants that might remain from system installation or even a retrofit. The analysis of some of these lubricant samples taken from actual systems have shown the oil to suspend and recirculate a high concentration of what size, Kevin?
In the 2 to 20 micron size particles.
With the largest percentage being in the 2 to 10 range.
Correct.
So all the more reason to address this. Although some particles are smaller than bearing tolerances, studies have shown bearing life can still be adversely affected. Bearing wear depends upon the size, hardness, and concentration of these particles in circulation. So now let's take a look at a way to help resolve that. Here we've got devices that can be used that will remove those 2 and 3 micron size particles. And we have filters that are built that can be serviceable, like you see here. And we have even hermetically sealed versions as well. Now, this happens to be an oil filter. It's a replaceable filter element. It has the call letters ROF. It's a replaceable oil filter. The image on the slide shows the flow path of the oil with the inlet fitting located in the end plate, as you can see right up here. It's got a drain fitted to it. This shows the replaceable filter element that you would utilize. And these particularly work best if they're installed in what kind of arrangement? Vertical. They're more serviceable if you do that. Now somebody might say, well, where does this go in the system? Well, here we've got an oil pressure. We got an oil management system depicted here, and we happen to show this a sealed model here, which you can put in a number of different orientations. Is that right, Kevin? You can lay it on its side like we show here in this depiction. But
Right.
The serviceable version would be better if it were in a vertical installation. If nothing else, you go to replace the filter element, you're gonna be glad that you organized it in that fashion.
Correct. Yes.
Now, the question oftentimes comes up: should oil filters, if you use an oil filter to help protect the compressor, should they be used to remove moisture? And on the surface, it seems like that makes a lot of sense. But let's just review some of these facts. Refrigerant has been calculated to hold 4 times more moisture versus, say, POE lubricant. The refrigerant passes through the liquid line filter dryer at a rate 5 times greater than oil passes through an oil line component. Dry down time is quicker in refrigerant versus oil. And if you dry the refrigerant, you will dry the oil because the moisture reaches an equilibrium within the system. Our contention, use a good filter dryer to remove moisture from the refrigerant in the liquid line. Use a good oil filter to take the particulates out and protect the compressor near the compressor in the oil management system. And Don, we're right at the end of what we have as prepared material. Do we have more questions that we haven't answered? Are you still with us?
Yes, we do. Yes, we do. One question that was asked is this: if a refrigerant line breaks and the system is exposed to high humidity conditions for 24 hours plus, can you rely on the filter to remove the moisture in the POE oil?
Well, I think that goes back to that slide where we had the reasons to remove or to replace the filter dryer, you've had a catastrophic leak and the system's been open for a period of time. I mean, in this particular question, he said 24 hours. I'd say the filter dryer that's there is within its limits, going to do what it can with its affinity for moisture to collect moisture. But to do the job right, I'd say you're going to have to do more than just rely on that filter dryer. The system's been exposed, it's been opened, it needs to be serviced and a new filter dryer installed. I don't care if it's ours or somebody else's.
Yeah, right, because there are limits of how much moisture it can sequester, right? See, at some point it's going to be saturated, right?
Exactly. And again, if there's any length of time involved at all, I mean, just like we've said in that earlier slide, in fact, I might, if I may, go back to your editing expert's going to want to fix this, what I'm doing to you here. If I go back to this slide, look at these reasons for putting in a new filter dryer. The system is open for service or repair. I'd say it's open for service or repair of anything. It's good practice to change that filter dryer. Now, many people don't do it. They think, well, okay, it didn't leak that long, and I'm gonna gamble a little bit. Sometimes the gamble pays off and it's not that big a deal. Other times it causes other problems that might not surface for a while.
Mm-hmm. Yep. So good. I think that answers the question. Now, here's one more question. Well, there's two questions. This next question is this. Why can ductless split systems get away with not having a filter dryer at all?
They have decided that in their manufacturing environment, that a good enough job can be done to curtail the presence of contamination, be it moisture or other things. In fact, they don't want you brazing or doing any kind of work on them. And they're of the contention that they've done a good enough job in their manufacturing environment that they don't want you to run the risk of adding any contamination to the system by adding another component or anything else to the system. That's the best I understand it. How effective that is and how that actually works out, I can't speak to that, but I think that's the thought, and that's why, for the most part, they want to use brazeless fittings in the field on these systems. They don't want you taking a torch to them in any way, shape, or form.
Yeah, I spent 14 years with LG Electronics, and that was their contention, right? So yeah, that's why they haven't. Well, not exact all the reasons why they have mechanical fittings, but you're right. They want mechanical fittings. In some places, they're kind of thwarted, like in Chicago, for example. They won't have a mechanical fitting. Everything has to be brazed in the city of Chicago, right? Yep. So there'll be places like that,
Yeah, and you got multiple things that work in an environment like that. You have, in some instances, and I can speak to this a little bit. You've got strong union presence, and I like from my father, for instance, taught folks how to braze and weld in a union environment, and they trust that. And they sometimes don't trust alternate methods.
Right.
And so you have to make decisions and decide which way you're going to go. There's merit to both.
Mm-hmm. Okay. And then this is the last question here. This has to do with the mesh screen that you had there. He says, I always thought that a 100 mesh screen was just in case the dryer broke up. Is that true?
Well, the 100 mesh screen is at the inlet of a thermostatic expansion valve, for instance, to protect it from anything. What might get trapped there could be the abraded desiccant material that would be in a filter dryer. Yeah. What if there is no filter dryer? What if there's other things circulating through the system? I've had product returned to us that had a pipe plug show up in the strainer. All right, that flowed all the way through the system, and for one reason or another, it wasn't removed. The lines were braced together, and it was entrapped in there, and it got caught by the strainer. So that strainer is there to catch large particles, whatever they might be.
Very good. And just one note to the audience, the handout is something that they can download. That's a reference for the material that was covered today, and that's theirs to keep for reference in the future.
Absolutely. And for more information, you can visit us on sporlan.com. We've got free literature. We've got access to training. We've got product videos. There are other videos that we've prepared, other webinars on a great many of our products. We also have our virtual engineer software program that is free for you to use, that you can use to size and select our products.
All right.
And any other questions, Don?
That's it. I think we've got it.
Well, thank you all. Don, thank you for letting us do this today, and appreciate everybody that's joined us.
All right, and many thanks too for you two guys, and also for everybody and their interest in getting their arms wrapped around good choices in filtering and drying seal systems.